Hey guys, welcome back to my channel GP Stories. So today we'll be solving problems based on generators in parallel, which has come in ETO, COC numericals. So before solving the problems, we'll list out the formulas which are required for solving the problems. So let's start. First is generators in parallel. Okay. So the formulas which are required, let's draw a triangle. Okay. Right angle triangle. This is a 90 degree. So this will be resembled as kilowatt, that is a real power. Okay. So this is the angle. Right angle opposite, that will be the hypotenuse. Hypotenuse will be referred as kVA, denoted by S, which is the apparent power. Opposite to the angle, that is the kVAR. Okay. That is denoted by Q, which is the reactive power. Okay, so all these problems are related to this terminology, that is kilowatt, kVA and kVAR, which is the real power, apparent power and the reactive power. So I'll list it down here. Kilowatt is real power, that is denoted by P. kVAR, that is the reactive power, that is denoted by Q, and the kVA, that is the apparent power, that is denoted by S. Okay, so now from this triangle, according to trigonometry, we can find out the formulas. So this is the 90 degree, this is the angle. So we know that cos phi is equal to adjacent by hypotenuse. So adjacent is the kilowatt. Adjacent angle is a kilowatt. The hypotenuse is the kVA, which is the apparent power. So sin phi, this angle is phi. Okay. So sin phi is opposite by hypotenuse. So opposite is kVAR, that is the reactive power, divided by kVA. Okay, which is the real apparent power. Okay, reactive power divided by apparent power. So according to trigonometry, there is a formula that is known as sin square phi plus cos square phi equal to 1. So we have to remember this formula. First formula is the cos phi, second is the sin phi, third is this. Now, fourth formula is that if two generators are running in parallel, then the real power kilowatt A of real power of generator A plus real power of generator B, that is the kilowatt B, is equal to the total power, that is the kilowatt total. Okay. Next one, same fifth one. If two generators are running in parallel, okay, the total reactive power, that is kVAR of A, generator A, plus kVAR of generator B is equal to total reactive power, that is kVAR total. Okay, so these formulas we have to remember. Remember that the apparent power of A plus apparent power of B is not equal to total apparent power. Only these are the total apparent power, that is kVA plus kWA. B is equal to kW total, and kVAR plus kVAR B is equal to kWAR total. Okay, Next one, let's go to the problems. These are the important formulas which are necessary. Okay. Okay. So this is the first problem, that is a total load of 8000 kilowatt at zero point 0.8 power factor is supplied by two alternators in parallel. Okay. One alternator supplies 6000 kilowatt at zero point 0.9 power factor. Find the kVA, that is the apparent power rating of other alternator and the power factor. Okay. So before solving this problem, the easy method is that what and all given in the question, please note it down so it will be easy for solving the problem. So it is saying that the total load of 8000 kilowatt, so of zero point 0.8 power factor is supplied by two alternators. So it means that there is two alternators that is running in parallel. So let's write generator A, generator B. Okay, two alternators are running, and so it is having total kilowatt of, so the total, so total, how much it is giving. So write the three parameters, that is generator A, generator B and total. Now here you write kilowatt, okay, kVAR, that is the reactive power, and kVA, which is the apparent power, and the power factor. Okay, now let's see the question. A total load of 8000 kilowatt. So the total load is kilowatt. So here it is 8000. Okay. Now at 0 0.8 power factor. So the power factor of total load is 0.8. Okay. Is supplied by two alternators in parallel. So two alternators in parallel. One alternator supplies 6000 kilowatt. Consider if generator A is supplying 6000 kilowatt. Okay, this is 6000 kilowatt at power factor 0.9. Okay, 0.9 is a power. Find the kVA rating of other alternator and power factor. So they are asking the generator B, other alternators kVA and power factor. So we have to find the generator B kVA rating and the power factor, how much it is. Okay. So before doing that, let's find the given parameters values. That is, we are having the power factor. So we know that power factor means cos phi. So for generator A, what is given? Kilowatt is given. That is kilowatt of generator A is equal to 6000. Okay. Cos phi is equal to 0.9. So we know the formula, cos phi is equal to kilowatt by kVA. So we can find the value of kVA, that is cos phi is equal to kilowatt divided by kVA, that is kVA is equal to 6000 divided by cos phi will come down, that is 0.9, that is equal to that is 6000 divided by 0.9, that will be nothing but 6.6667. Okay, this is the value. So this value, write it down here, kV. How much is the kV? That is 6.6667. Okay, this is the value we got. So we got kVA. So we have kVA. Then one more formula is here, that is the sin phi. Sin phi is equal to kVAR divided by kVA. So we can find the kVAR. Okay. So sin phi is equal to kVAR divided by kVA. Okay. We know the value of kVA. We don't know the value of kVAR, and we don't know the value of sin phi. So how can we find sin phi? We know the formula, that cos square phi plus sin square phi is equal to 1. Okay. So sin phi is equal to root of 1 minus cos square phi, that is equal to root of 1 minus, what is cos phi? Cos phi is 0.9 square. So the value will be root of 1 minus 0.9 square. That will be none other than 0.4359. Okay. We can add here one more column, that is the sin phi column. Sin phi. Okay. So we got the sin phi value as 0.4359. So write it down here. 0.4359. Okay. Now we want the value of this two. Okay. So to find these two values, we have to find all the values. Okay. Next, we got sin phi. Now we have to find the value of kVAR. kVAR is equal to sin phi into kVA. So what is sin phi? Sin phi we got 0.4359. kVA we got. So multiply that. 6.6667 into 0.4359. So that is none other than 2906. Okay. So we got the value as 2906. Okay. So we got the value of this both. Now this is for generator A. Okay. Now let's go to the total. We know that kWA plus kWB is equal to kW total. So we can find the value of this value kW of B by this formula. So what is that? That will be 8000 minus 6000. It is 8000 minus 6000. That value is 2000. So we got this value 2000. Okay. Now we know the value of power factor. This is 0.8 for cos phi. For total, this is for total. Okay. Total, generator total. So cos phi is here is equal to 0.8. So what is the value of sin phi? So we know the formula for sin phi, that is root of 1 minus cos square. So sin phi will be 1 minus 0.8 square. That is none other than 0.6. So we got the sin phi value, that is 0.6. 0.6. Okay. Now we have to find the value of kVA. How to find the value of kVA? We know that cos phi is equal to kilowatt total divided by kVA. We know the value of cos phi, we know the value of kilowatt total. So what is kVA? kVA is kilowatt total divided by cos phi. That is kilowatt total is 8000. 8000 divided by 0.8. Okay, cos phi. So that will be 1000. Now 10,000 or 1000. Okay, that will be 10,000. So kilowatt total we got as 10,000. Okay, we got the value of kilowatt total. Now kVAR. How to find kVAR? kVAR is equal to sin phi into kVA. Sin phi into kVA. So we know the value of sin phi. Sin phi is 0.6 into kVA. kVA is 10,000. That will be 6,000. This is 6,000. Okay. So all these values we got. Now we can find the value of this both. That is how. You know the formula that kVAR total is equal to kVAR. You know the formula. kVAR A plus kVAR B is equal to kVAR total. So we don't know the value of kVAR B. Okay. So to find the value of kVAR B, we can kVAR total minus kVAR B. That will be 6,000 minus 2906. That will be 3094. Okay, we got this value. Now we have to find the kVA and power factor. So how to find this value? For that, kVA. Okay, I'll do it in the next page. Okay, so see here. We have so for generator B, we have kilowatt of B, that is equal to 2000. Okay, kVAR of B, that is equal to 3094. Okay, we want kVA. We know that cos phi is equal to kilowatt divided by kVA. We don't have cos phi, but in the triangle there is a formula. Okay, this is a triangle which was in, this is kilowatt. Okay, this is kVA, this is kVAR. Okay, we have kVAR and kW, so we can use the Pythagoras formula, that is kW square plus kVA square is equal to kVA square. Okay, so kVA is equal to root of kW square plus kVA square. So what is kW here? 2000 square, 2000 square plus 3094 square, that will be equal to root of 2000 square plus 3094 square, that is none other than 3684.1330. Okay, so we got the value of kVA of generator B, that is 3684.1330. Okay, now we have to find the power factor. What is the power factor formula? Cos phi is equal to kilowatt divided by kVA. What is kVA? Kilowatt. Kilowatt we know, which is 2000. Okay, 2000 it is. So 2000 divided by kVA, that we have found out, 3684.1330. So that will be equal to 2000 divided by 3684.1330. That is none other than 0.5429. Okay, so we can write it here, 0.5429. Okay, so I'll explain the problem once again. Okay, so listen. A total load of 8000 kilowatt, total is kilowatt, that we have written here, and power factor is written here of total, is supplied by two alternators. So there are two alternators, generator A, generator B, in parallel. One alternator supplies 6000 kilowatt, so one alternator we have written as 6000 kilowatt at a power factor, that is 0.9. So we have to find the kVA rating of other alternators and power factor. Okay, other alternator kVA and power factor we have to find of generator B. So to find that, it is given in generator A, it is given kWA is given, 6000 is given, cos phi is given 0.9. So we have to find kVA. We know the formula, cos phi is equal to kilowatt divided by kVA. We found out the kVA. We got the kVA. Okay. Now sin phi we have to find. Sin phi what? kVAR divided by kVA. But to find sin phi, we don't know sin phi. So we are using this formula, cos square plus sin square is equal to 1. So sin phi we got 0.4359. After that we found out kVA, that is multiplying by this sin phi into kVA. So we got 2906. So this we found out, everything is found out. Okay. Now coming to total. In total, this, there is a formula we have written here. Okay. kVA plus kWB is equal to kW total. So kW total is there, kWA is there. So we can find kWB. So by this formula we have to find the kW, that is 8000 minus 6000 is equal to 2000. This we found out. Cos phi of this is given total, that is 0.8. So we can find out sin phi by this formula, cos square plus sin square is equal to 1. Sin phi we can find for this, that will be 0.6. Cos phi is kilowatt kWt plus kW divided by kWa. So kWt we know, that is 8000. kWa we have to find, that is kWt divided by cos phi. Cos phi is 0.8, that is 8000 divided by 0.8, that will be 10,000. Now we can find kVA, that is sin phi into kVA by this formula. Now we got all these parameters. Okay, we have to find kVAR. kVAR we can find how much? 6000 minus 2906, that will be 3094. To find this, okay, we can use the Pythagoras formula. That is what you know. So KVA, KWB is given 2000, KVA RB is given 3094. Cos phi is there. Cos phi is KW by KVA. Okay. Pythagoras formula is that hypotenuse square is equal to KW square plus KVA square. So by this formula we got the value of KW square and cos phi we found out. So we got these two answers. If any doubt is there, you can please put it in the comment section. I will explain again. So this is a method. I hope everyone got the method. Thank you.